This is exactly what it says it is. It's just a series of hints when you get stuck on the review for the practice set for the final exam. I'm going to be very brief and just go through this quickly because it's supposed to be just a bump if you get stuck. I would suggest that you don't go straight to the hints, that if you can't work a problem, go back and look through your notes, rewatch the appropriate lecture video, try again, and then go to the hints. If you go to the hints too soon, I'm afraid you're not doing yourself a favor because you really need to try to learn this on your own, make mistakes, figure out what you did wrong, and you learn by doing that. But when you do get to the point where you just cannot go any further, that's the point that I would look at, and just look at the hints on the problems that you're stuck on. I don't want you to get too dependent on these. Having said that, I'm just going to very, very briefly go through this to give you a few hints. Number one, this is a problem. It tells you the hint right into the instructions. It just says to use direct substitution. That simply means you just need to plug the 9 in and get an answer. Same for number 2, same for number 3. Number 4, you're given a rational function. You're supposed to describe the intervals which function is continuous. Remember, a continuous function can be drawn without picking your pen up from the paper. And so if you look at the function, you can see that it's only defined for values greater than 0. But for values greater than 0, it is continuous. So if you look at that graph, you should be able to figure that out. Identifying any discontinuities, again, based on what I've already said, and looking back at that graph and realizing that you're just looking at the graph that's already there. The answer should be obvious. So I'm not going to say a lot more about that. The bottom line on this hint is if you look at the graph, you should be able to answer those questions if you understand what continuity is. Number 5 is another continuity problem. Now, these problems where the function is defined by more than one rule, the most likely break in continuity is where the rule changes. And in fact, each of those pieces is a polynomial, and as we should know, a polynomial is continuous everywhere. So the only place that a jump could occur, a break in the continuity could occur, would be at the place where the rule changes, and that's at 8. So you need to consider what happens to the top part and the bottom part when x is equal to 8. Same sort of idea here as with the others. The graph is already given to you. Continuity implies that you can graph it without picking your pen up from the paper. But differentiability is a little stronger condition, and you don't have differentiability when you have, among other things, when you have a sharp corner or some kind of cusp. This one asks you about differentiability as well. Another place where derivatives aren't defined, where you don't have a function being differentiable, is at a domain endpoint. And you can see here where the domain endpoint is. So again, that should be enough to get you through that one. Number 8 is a rational function. You're looking for differentiability again. You can see that those vertical asymptotes break the function into 3 pieces. And again, because you have the graph, if you understand what you're looking at, the answer should follow from that. Again, differentiability. And again, looking at where the function has a jump. The nice thing about these last few is that they've already drawn them for you, and if they do that, it makes the rest of the problem pretty easy. Number 10 is just a simple power rule for derivatives, doing it term by term. Same thing for number 11. Same thing for number 12. 13 is a product rule. You have to remember the product rule. Here you're dealing with the marginal cost, and are you looking at finding the marginal cost given the cost function? The marginal cost is the derivative of the cost function. And number 15, the marginal revenue is the derivative of the revenue function. And number 16, the marginal profit is the derivative of the profit function. 17 sort of gives a hint you're using the product rules. You have to know that. 18 is a quotient rule problem, so you got to know your quotient rule. 19 is a quotient rule. 20 is a chain rule or a general power rule, however you want to say that. The derivative of u to a power is bring the power down, reduce the exponent by 1, it becomes n minus 1, and then you take the derivative of the inside, which is indicated here in this formula by u prime. 21, same as 20, use the chain rule or what you might call the general power rule. 22, same thing, but I would change the thing raised to a 7th power in the denominator to that thing raised to the negative 7th power. If you don't, the way it's written in the original form, you would have to use a quotient rule, but I would recommend writing that 7th power as bump it up and make it negative 7 power and use the general power rule instead of the quotient rule. Second derivative means you've got to take the first derivative before you can get to the second derivative. Third derivative means you've got to find the first and second derivative before you can get to the third derivative. The fifth derivative means you've got to take they start you out with a second, so you don't have to worry about doing that one, but then you got to go to the third and then the fourth and then the fifth. 26 says you want to find dy over dx. That means you want to find the derivative. Since that function is not solved for y, this is going to be an implicit differentiation problem, so the strategy is to take the derivative of both sides, remembering when you take the derivative of y, you get dy over dx. 27, you could use implicit differentiation here. I would recommend that you multiply both sides through by the denominator, which is x minus 3y, and simplify and collect like terms. And if you do it that way, however you proceed from there is simpler than doing it directly in the form that it's written in. And in fact, this problem I think is so simple you could actually solve for y and do it without doing implicit differentiation. But whichever way you choose to do it, if you multiply through by the x minus 3y before you start, I think you'll be ahead of the game. 28, you find the slope of the tangent line. That's the derivative. This function is not solved for y, so it's going to be implicit. So you take the derivative of both sides, remembering that when you take the derivative of y, you get dy over dx. And then when you get the result, you can plug in the values minus 1 for x and 1 for y. And honestly, if you're thinking about it, if you plug in sooner rather than later, the algebra becomes easier. So if you can see the last step that I wrote down here, you could keep going and find dy over dx. That's a lot of algebra. Really, at that point, you could just go ahead and plug in the minus 1 for x and the 1 for y and work it from there. I think that would be easier. Works either way, but it would be easier if you plug in the actual values of x and y earlier. Again, I think the graph says everything on this one. You want to show that that function is increasing and decreasing on the given intervals, and they're just asking you to fill in the blank. So you have, if you have the derivative, if you have y is equal to x to the 6 plus 2, then of course y prime is the derivative of that, and that derivative is 0. Well, you have to solve, set the derivative equal to 0 and see when that happens, and that gives you your critical numbers. And then you can check on both sides of it to get your increasing, decreasing behavior. And they're just asking you to fill in the blanks there. This problem, again, asks you to find critical numbers. So you have to take the derivative, set it equal to 0, go through the process you've always done, create your increasing, decreasing chart, and so on and so forth. This one wants to find all relative extrema, so you know to take the derivative, set it equal to 0, find your critical numbers, test them out with your increasing, decreasing chart, and the same thing we've done in the past. 33, you want to find the absolute extrema. Remember, when you're doing absolute extrema, you have to consider the endpoints as well, and you're looking for the absolute highest point and the absolute lowest point. So I think if you just read through this, you can see what the hint is. You want to compute your y values for all your critical numbers. That means you got to find your critical numbers. So step 1 is take the derivative, set it equal to 0. You get plus or minus 3. But remember, the interval you're checking on is 0 to 6. So negative 3 is not in the interval, so you can just toss negative 3. So what you've got to do is you've got to test 3 and see what its y value is. But you also have to test the y values of the endpoints 0 and 6. And that's what this chart over here is all about. So take it from there. When you're given the graph and you're asked for it to satisfy conditions, I would say the strategy is to find the one that satisfies all the conditions, and you can start off by eliminating things that definitely do not satisfy the condition. Concavity involves taking the second derivative. There's a problem with this problem. I would say just ignore this. You're not going to see this flawed problem on the final. Want to sketch the graph. Again, you're just picking out the graph, the one that satisfies the condition. You want to find, there's only one graph that satisfies every one of those conditions, so one of the strategies is just to eliminate possibilities. If you notice that the first condition says that f of 0 and f of 6 are 0, that knocks out the second and the fourth possibility. That only leaves you 2. And that last possibility says that the second derivative is positive. That means it's concave up, so that should give you the impetus to get to where you need to be on that one. Word problems, you're going to draw the picture. You're given the perimeter is 84, but you want to maximize the area. The next one, you're given you know that you want the area to be 100 square feet, so x times y in my graph here, and the way I've drawn it is x times y is 100. But you're trying to minimize the perimeter, which is 2x plus 2y. So p is the function you're trying to minimize here, given that extra information that x times y has to be 100. This one is a fenced-in area around a river, so you only need 3 sides. So you call the sides that are perpendicular to the river y, and the other x. It doesn't matter what letters you use, but that's one way to do it. And you're given that the area is 125,000 square meters, so that allows you to figure out what y is in terms of x, but you're trying to minimize the amount of fencing. Well, the amount of fencing is not 2x plus 2y because you don't have that fourth side, it's just x plus 2y. Find the number of units that produce a maximum revenue. Again, you take the derivative, set equal to 0, and do all your algebra. You want to minimize the average cost. The hint here is that the total cost is given. You've got to find the average cost. The average cost is the total cost divided by x, and that's the function you have to minimize. This time you're doing advertising. That's the P function is the profit, and so the point of diminishing return has to do with inflection point. So you're going to take the first derivative, set equal to 0, do your normal stuff there to find your maximum profit. But then when you answer the second part, you've got to deal with the second derivative. The second derivative tells you about diminishing returns. To do the derivative of an exponential, you've got to remember the formula. The derivative of e to the u is e to the u times u prime. Number 45, you've got a product rule, and within the product rule, you're going to have an exponential. So you're going to do the product rule, and when you get to the derivative of v, you've got to go to your exponential rule. 46, you're doing implicit differentiation, so you start off taking the derivative all the way through, remembering that you're going to be using the product rule here and the exponential rule. 47, you've got to use the log rule. The derivative of the log of u is u prime over u. 48, you've got a quotient, but the numerator is going to be a logarithm, so you got to remember that. So you've got the quotient rule and the log rule. You're doing an implicit differentiation, but it involves a logarithm, so not only do you have a quotient rule, but you have a log rule. And after you do the first derivative, first pass through on those derivatives, you'll see you've also got a quotient in there. Now we're doing some integration problems. That's simple. The antiderivative of 3t to the 4, so you're using the power rule for antiderivatives or for integrals. Here you're going to do term by term, but you're going to use the power rule for integrals, but you're going to do it term by term. Here you just got to remember you're given the marginal cost and you want to find the cost, so that will be a integration. And the fixed cost is what happens when x is equal to 0. That's the additional information needed to find what c is. So you got to use that last information to find out what c is. Here you can do a substitution and let u be x squared minus 2 and then take it from there. Here's another substitution. You're going to let u be 3 minus 4x squared. Take it from there. Here's the substitution. You're going to have u being 2x cubed plus 5. Take it from there. This one you're going to let u be the exponent, which is 4x minus 3, and take it from there. This one you're going to let u be 8x minus 7 and take it from there. Here u is going to be 9 minus x to the fourth. Take it from there. Find the area, you just integrate the function from, in this case, 1 to 16. Take it from there. Evaluating definite integral, you take the antiderivative of the integral and you evaluate it from the top limit minus the bottom limit. Again, a definite integral, you take the integral of the inside, but then you have to evaluate it top minus bottom. The area between those two curves, the top curve is f and the bottom curve is g, so you're going to do f minus g and you're going to integrate from 0 to 1. This curve crosses, but there's also a symmetry, so rather than evaluating from 4 to 5 and 5 to 6, if you notice the symmetry and you notice that the area from 4 to 5 is the same as the area from 5 to 6, you can just pick one of them and double it. So I would take either the area from 4 to 5 and double it, or the area from 5 to 6 and double it. And again, from your algebra, you should know what y equal x squared looks like, and you can plug in a few points and find out what 2 minus x squared looks like if you don't. But you should be able to figure that out pretty easily just by drawing on your algebra. And then to find the area of the region, you just take the top curve minus the bottom curve and integrate it from minus 1 to 1. On these, you're just plugging the numbers in. And again, here you're just plugging the numbers in. You have to know how to use your calculator, though. Again, you're plugging the numbers in. Please practice your calculator. Partial derivatives, we've just covered that so very recently, so I'm not going to say a lot about that. You've got to figure out which one you're holding constant when you're doing one partial versus the other. And again, I'll say the same thing here, but it also involves the product rule and the exponential rule. Even when you're doing partials, all these other rules can come into play. The same thing here. This time you're going to get the log rule involved. You still have to go in and decide what you're holding constant each time. And again, the max min saddle points are the 7.5 material. We just covered that. You've got to normally calculate your d value. They gave you the second partial, so they did the hard work for you. So all you've got to do is take the second partials they gave you. Normally you have to do it yourself, but they gave you the second partial, so you just got to compute d and then use the conditions of the d test to figure it out. Same thing here. And same thing here. And that's it.